Hello friends, welcome to CEC Live Lectures. Dear friends, today in this session we are once again going to talk on software engineering. We have conducted one session on it and we tried to understand what software engineering is. Today we are going to discuss on processes, and for the discussion we have with us in our studios Dr. Pavitra Bharadwaj. Dr. Pavitra Bharadwaj is Assistant Professor in Department of Computer Science, Jesus and Mary College, University of Delhi. Friends, if you have any question pertaining to today's topic, then feel free to talk to us through our toll-free number. Our number is 1800110430. I repeat, our number is 1800110430. Now, I would like to welcome our guest, Dr. Pavitra Bharadwaj, and would request her to give us in-depth knowledge on the topic. Hello, ma'am. Welcome to the lecture.
Thank you. Good afternoon. In the previous lecture, we had started our discussion on a very important and very prominent area of computer science, that is software engineering, and we had covered the introduction part: what is software engineering, what is a software, and what are the various types of programming techniques which have been used for software developing and software engineering purposes. So basically we had seen that software engineering is a specific branch of computer science or computer engineering, wherein we talk about development of programs and softwares for achieving some business goal. And the main aim of software engineering, we have actually threefold aim of software engineering. First is improving the quality of the software or the processes which are going on. Second is to complete or to minimize the time taken for the requirement of the development of the software processes, and the third is to minimize the cost. So basically it is a threefold approach towards the quality or enhancing the productivity of software engineering. In today's lecture, we will talk about the various ways in which software development takes place and what is the process of developing a software. When we are talking about process, basically we mean the steps which will be followed, the order in which the steps will be followed in order to achieve the goal of, as I just said, the goal of maximum quality, minimum cost, and in the least amount of time period. So basically, generally in software engineering, the approach which is followed is a phased development process approach which is followed. That is, the development process, the software which is developed, it consists of various phases, and each phase ends with a defined output. So basically what we are doing in the phase development procedure or the process, that the entire problem is developed or is broken into a set of simpler, smaller problems, and these problems of developing software are smaller, and therefore these are successfully performed in a set of phases. So basically this will critically reduce the cost of development of, if we talk about the cost of development of a software in one go, so instead of that we are doing a phase wise development, so the cost of development of the overall product becomes less, and also we can check for the quality and progress at some defined points. Because if you talk about a software and if you think that it is a one go process and you have one starting point and one end point, then you cannot determine the quality, or you cannot determine the timeline, or you cannot determine the schedule of the process. But if you are following it in a phased manner, then for each phase, after each phase is over, you can find out what is the quality, what are the parameters for quality, you can test your product on those parameters, and you can also match the schedule, the timeline of the product with the planned timeline or with the schedule can be measured. So basically the process of software development is a phase development process where the entire process of the problem domain has been divided into multiple sub processes. So basically software process is any process means anything that operates for a period of time, normally continuing resources during that time and using them to create a useful result. So basically we are using some resources, we are consuming some resources, and we are giving the output based on that. So basically it is a set of activities whose goal is the development or evolution of a software. So the whole thing is known as a software process where you have certain activities. So when we talk about these activities, there are a few generic activities which are followed in all software processes. So first process or the first activity in the software process is the requirement specification, wherein what the system should do and its developmental constraints are decided. The second step or the second part of the process of software development is the design phase, that is you design or you decide a plan for a solution. Then the third part comes to development, which means production of the software system, which here means basically the coding, that is whatever design has been made, that is developed into, that is written down into a program code. And then we have validation, which means testing the software according to the requirements of the user and according to the performance standards which have been less. And then finally we have evolution, so which is changing the software in response to the changing demands of the people. So we will be talking about each of these steps in the course of this lecture, that is what is requirement specification, what happens in the design, what is development or coding, then what are the different types of testing strategies which are adopted, and what happens at the time of implementation and further change of processes. So basically the software development process, it encompasses several challenges, or there are a lot of issues which are faced by software development process. First issue which is primarily faced is that the requirements are very complex. That is, the client are themselves not sure of what they actually want, because many a times there is no system which is existing before the software is going to be made. So therefore the client himself is not sure and have no clue, as in no practical idea of what software is required, what are the requirements, what are his needs, what are his expectations from the new system which is being developed. Then second point or second challenge which is faced in software development is that the requirements are constantly changing, because there are so many issues which lead to this problem that the requirements change. Firstly, the most simplest could be that the user once he starts looking at the system, then certain new ideas come to his mind. So that is one thing. Then adaptation or technology or new possibilities are there for the non-functional requirements, those can be added. Budget can be changed, or some environmental factors can also make changes, some factors which are out of the control of the consumer. For example, new tax regime has come in, or new rules of calculation of wages are there. So all these also require the software to change. Sometimes even while the development is still on, the requirements of the user change. Then frequent changes are very difficult to manage also, because you have to identify the milestone, and then the cost estimation becomes difficult, because initially the cost is calculated according to a specific set of requirements, and if those requirements change in the due course, then certainly the cost of the project will also change, and therefore it will become very difficult to estimate the correct cost of the project once the requirements are constantly floating or they are constantly changing. Then there is no more than one software system. That is, new systems must often be, they should be backward compatible with the existing system if there is any. If you are using a legacy system, then the new system which is developed should be compatible with it. It should be able to port data from it. It should be able for it should be very user friendly. The interface should be not very different from what the users are accustomed to use, because otherwise it will be a problem in acceptance of the new system by the user. So phase development basically needs to distinguish between the system under development and the already released system. So basically the phase development will remove this kind of difficulties, because after every phase the system which is being developed or which is being prepared will come with a document, will come with a specific set of output that can be used and that can be checked. So basically, what is the way forward or what should be done? That is, this led, because of all these issues, this software crisis led to a push to improve the way in which software development is taking place. So basically, it became very necessary to understand how the software is developed, and people also understood that what is commonly known as programming is not just writing code in a programming language or just making the logic for a program, but it encompasses a lot of other activities. So software development is not just coding or writing the programs for performing the specific set of tasks, but it is a huge exercise which encompasses or which entails a larger other number of activities than just programming. So therefore, this kind of approach is to be kept in mind before a software development idea is to be floated by, or if it should be floated for a particular client. So before we actually start into the processes of software development, we first like to understand a few terms which are very commonly used. So the first term which is used is software lifecycle modeling. So it is an attempt to deal with the complexity and change. So software lifecycle is basically like we have the life cycle of any other organism. For example, if we take the life cycle of a butterfly, so then after every stage or after every phase of the development, a new product or a new organism is coming out. So similarly, that is a life cycle, that is from an adult, you have an egg, and then so on and so forth. Similarly, this kind of a modeling is required, that is some type of prototype is to be developed. Then software life cycle means all the activities and their relationship to each other which support the development of a software system. So basically, this is a complete life cycle which encompasses a large number of activities, and primarily the activities which I had discussed just now. And then we have software development methodology, which is a collection of techniques or building models applied across the software life cycle. So these are specific methodologies, specific techniques and tools which are used for building the models of the softwares. Then we have the life cycle phase, which means a series of identifiable stages that the software product undergoes during its lifetime, and these stages are known as life cycle phases. So the software product also has several certain phases in its life cycle which needs to be taken care of and which are also important to be understood. Then we have breaking software development down into a number of phases, like these led to the idea of a software life cycle. So we've just said that the software is not one step procedure, but it has several phases in its development, and all these phases, they are interconnected to each other. And it is also important that each phase must be critically identified and it must be critically understood. So basically, now we are going to talk about what are the main phases which are required. So the first and the foremost process which is discussed in when the software development initiation starts, or when a company starts to think about getting a software made, is firstly generating the request, or first is system conception, that is discover and document what the system or what the software should do. Basically the client, this is at the client's end, which is important to understand, that is a need of the software is felt, a need for an automation system is felt at the client's end, and they decide that they require something of this sort to perform a certain set of activities. After this, when the requirement or when the request has been generated, then the software company comes into the forefront, and then they start with their activities. So the first and the foremost activity which is important in any software development life cycle is first the requirement specification phase. So basically, in the requirement specification phase, it is deciding what the system is going to do. So basically, what the system is going to do means that in this phase, the software developers or the people in charge of taking up the software development project, they interact with the client or the customer for whom the software is to be developed. And once the software is developed, or once the requirements are understood, only then the next phase can begin. So requirement specification is a very important exercise in terms of both effort and in terms of both time put into the system. So we can say that 10% of the effort of the system development life cycle is put into the requirement specification, but still this is very critical, because if the requirements are not assessed correctly, then the entire, because this will have a cascading effect on the other phases of the software or on the other steps of the software development life cycle. So what is given after the requirement specification is done, what is obtained is a requirement specification document. So this requirement specification document, it not just has the user's requirements or the user's needs from the system, but it also has all the other important factors like what are the security constraints, what are any other kind of environmental or governmental or procedural constraints which will be implied on the software. So basically this document is very important because it will be the foundation of what the building of what the software finally is going to evolve as. After the requirement specification phase, we see that the software design phase comes into plan or it comes into existence. So in case of software design phase, it is basically in the requirement specification phase, we have seen what the system is supposed to do. In the design phase, it is basically how the system is going to do this. So it is creating the software which implements it. So in this case, a detailed plan is laid out and a detailed design is laid out, so that what the requirements are, how these requirements are going to be fulfilled or how these requirements are going to be met. So when we talk about software design phase, in this phase 3 level designs are done. The first phase of design or the first level design is the architectural design. So in this case, the main components of the system, they are identified, what are the main components of the system and how they are going to be integrated to each other. The second is the high level design which is done. In this case, all the modules of the various components, they are understood, and in the third phase, which is the detailed design, the logic of each of the modules is designed. So basically in this phase, the entire system's layout or blueprint is prepared according to the requirement specification document which has been obtained. So this is also another important activity, and also it requires about 10% of the effort. Now after the design has been created, after the logic has been written, then the next phase or the next step in software development life cycle comes, which is known as the coding phase. Now in coding, basically in the design phase, it's only a plan which has been written, it's the logic which has been written, but in coding phase it is actually coded in the form of programs, in the form of instructions which are written in a high level programming language. So whatever programming language is selected, in the coding phase, programs are written in that. Now coding is very important because it takes about 30% of the effort, and otherwise it is assumed that coding is the most important activity in case of software development, but that is not so, because more time and more cost is given or is levied on testing and maintenance than it is on coding. So basically programmers who are responsible for writing the codes also, they do not spend maximum of their time on coding, but they also spend it on other things. So basically in case of coding, it is the programming code which is written using a programming language by the different programmers. After the code has been written according to the design which was specified in the detailed design, then the next phase which comes is the implementation phase. So in case of implementation phase, the product is ready to be deployed at the customer. But when integration is done, before that an integration phase is also carried out. In integration phase, there is 3 levels of integration which is done. The first level of integration is known as unit integration. The second level of integration is known as system integration. So these integration phases are done so that each of these simpler attributes or simpler modules, they are integrated and an entire system concept is created. The software which is developed is working in the form of a proper system. So after the system integration has been done, the next step which comes in is known as the testing phase. Now testing and maintenance is the most important and the most cost bearing system, because in this phase the software quality assurance activities are done. So to make sure that the software is doing what it is supposed to do, testing and quality assurance is very important. Now for the first 2 phases, there is only a document which is required and which is produced, so only that document can be tested. But for the output of the coding, of course the programs can be run on the computer and the output, the desired outputs can be tested. So in testing also there are different types of testing methodologies which are checked. First testing is known as unit testing, that is the working of individual modules or individual programs or individual components is done. The second level of testing is an integration testing, in which the integration or the aspect whether all the modules when integrated together, whether they are working or not. And the third type of testing is known as the system testing. So in system testing, basically the entire system or the working of the whole system as one unit is done. So the testing procedure is very important, because any errors, any bugs, any kind of defects which are there in the system, they can only be identified at the testing phase. And the sooner the testing is done, the more the errors are identified, the better it is, because then the quality of the software will not be compromised. So after the testing has been done and the software has been assured for its requisite quality standards which it ensures, then the installation is done. After the installation of the system is done at the user's end, acceptance testing is also carried on. Acceptance testing means whether the user is satisfied or the user accepts the way the system is working, or the user's expectations have been fulfilled with the system or not. So it is basically the software is doing what it is expected to do by the user of the software or not. After this, the last and the longest phase of the software development life cycle, that is software maintenance is there. So we all understand that more cost of the software is given in maintenance than in development. So development maintenance will ensure that the software is up to date, it is according to the latest technological and systemic developments which have taken place, and it is meeting the user's required set of goals and objectives. So once the software maintenance phase is it is a prolonged phase, because constantly upgradations and updations are required in the system, and these are done by the software providing company. So basically these are the important phases of the software development life cycle. So if you see here, the software development phases are categorized as pre-development, development phases and post-development phases. So basically pre-development phases we classify requirement and designing as the pre-development phases. The development phase is basically the coding phase, where the proper code or the program logics are written, and post-development phases will be the testing, validation and also the maintenance phases. So the entire process of software development has been categorized into these 3 sections, that is pre-development, that is where it is ascertained on what the software is expected to do and how the software will do that. Development phase means actually implementing that the plan which has been prepared in the design phase, using a coding language, writing the computer codes and also making modules work with each other in the form of a system. And once the system has been developed and deployed, then before that you have the testing, which is a post development phase, and once the testing has been done, then you come to the maintenance and implementation of the system. So implementation is done, and then constantly the phase of maintenance keeps on going. So in the pre-development phase, the focus is basically on what information is to be processed, what are the functions and performances which are desired from the system, what are the various interfaces which are established, and what are the validation criteria which are required to define a successful system. So all these, the focus basically is on what part of the system, what are the interfaces, what are the criteria, what are the constraints, what are the functions, what are the objectives of the system. So this is the pre-development phase. And now in the development phase, the focus actually comes on the how part, that is how things are to be done. So in this case you have the three things, that is designing, coding and testing. So how data structures are designed, how the software architecture is to be designed, how details of procedures are implemented, how these details are translated into a code, and how testing will be performed. So the development phase talks about the how part, and the post development phase basically is the maintenance phase, which focuses on the changes in the software which are corrective changes. If there is any bug or any error which is reported, then the newer version of the software is to be given to the user, which is bug free or error free. Then we have the adaptive changes. According to the change in the environment, the software needs to be updated. Then these are perfective changes which will make the software absolutely bug free and work according to the user's need. And the preventive phases, where we have any kind of foresight is seen and the errors in the software can be rectified. So we shall be continuing in the next part of the lecture. Till then, thank you.
Thank you, ma'am. Thank you so much for giving us this session. Friends, you are requested to be with us. We are back after a short break and will be discussing more. Thank you. Hello friends, welcome back to this session. Friends, as you know that we are talking on processes of software engineering, and for the discussion we have with us in our studios Dr. Pavitra Bharadwaj. Dr. Pavitra Bharadwaj is assistant professor, and she is assistant professor in Department of Computer Science, Jesus and Mary College. Friends, if you wish to ask a question pertaining to today's topic, then feel free to talk to us through our toll-free number. Our number is 1800110430. Now, I would like to welcome our guest, Dr. Pavitra Bharadwaj, once again. Hello, ma'am. Welcome back.
So, we were talking about the various phases in the software development. Now, we are going to talk about the software processes. So, basically, the software process is a method of developing software which is used. Now, how do we define a software process? So, it is a set of activities together with ordering constraints among them, such that if the activities are performed properly and in the accordance with the ordering constraints, the desired result will be produced. So this is the definition of software process, whereby we understand that these are multiple activities which are to be performed in a given order, and if you follow the order and if you perform the activity correctly, only then you will get the desired output. Now I would like to tell you here that the desired result in case of a software is not just a proper working software, but it should be also meeting the timeline constraints, it should also be meeting the cost constraint, and it should of course be of the particular quality standards. So all these three things should also be met before the software developed software is said to be of a specific quality or of a specific desired output quality. So basically when we talk about software processes, so what you can see here is that the software processes, they are when any software company which is working is taking up several processes. So even if the company is a software development company, but it has two types of processes. First type of processes, which are of course the software engineering processes, which include all the technical and management processes which are required for the development of the software, for the project management, and for all the activities which are related directly to the development of programs and software. The second set of processes, there could be multiple such processes which are going on in a software company, which have got nothing to do with the development of software, and these processes, they are known as non-software engineering processes. So non-software engineering processes, like these are social processes, these could be business processes, networking processes, training processes, which are also going on simultaneously in the company, but they are very, very different from the proper mainstream software development processes. So what we are going to focus on in this session basically is the software engineering processes which are taken up by the different software companies which are working in the problem domain of software engineering. So basically what we talk about is a process model which specifies a general process, that is a set of stages in which a project should be divided. Now the order in which the stages are to be executed and any other constraints or conditions are also a part of the process model. So basically this leads to low cost, high quality and low cycle time. So these are basically generic guidelines for developing a suitable process for a project. So when a software project is taken by a company, there are specific activities to be done, and these activities are flown according to certain guidelines. So basically these are generic guidelines and each project is different. So the duration for every activity in every project may not be the same. In some projects the one activity could take more time as compared to the other activity. So each project therefore has these generic guidelines to be tailored according to its specific requirements. So these are very broad outlines which are to be followed by any kind of software project team, and if these guidelines are followed, certainly the quality issues and the quality and productivity issues of the software can be confronted with. So basically when we talk about software processes, the software processes are different, can be divided into two sets of processes. The first set of processes are known as the product engineering processes. In these product engineering processes, basically we are talking about three things. First are the development processes, the second are the project management processes, and the third are software configuration management processes. So these are the three set of processes which are followed in case of software product engineering processes. The second set of processes which are basically process management processes. So now we are going to see about each of these processes, that what are each of these processes for. So the first process which we called as the development process. So when we are talking about development process, we are basically meaning the coding and the designing the plan or laying out the strategy on how the software is to be created, what is the constraints, what are the security, what are the other kind of conditions and constraints on which the software is going to work. So all these processes will encompass the set of activities which are related to designing the software, then developing the logic and writing the code of the product. And also alongside, it will also mean that the testing phase or the testing part, testing, validation, all has to be carried on in this development processes. Now when many a times we see that when a software is being developed, besides the developing, there are a lot of other issues which come up. So all these issues which come up, which require some kind of management approach, like assigning work schedules or cost benefit analysis or taking critical strategic decisions on the project deadlines or on the project cost, all these decisions are also taken through a set of specific systematic activities which are as a part of the process management or the project management processes. And then many a times we also see that the requirements of the software change, or there are so many requests for changes to be made in the software once it is developed or while it is still developing. So all such processes which take care of the changes to be brought about in the software or any kind of updation or modification to be brought about in the software, such changes, they are known as the system configuration management processes, which are going to in some way alter the configuration of the system. Besides this, there are many error management processes and other processes also which are a part of the product engineering processes. The second set of processes which are followed by the software process is the process management processes. That is, a specific high level team is responsible for ensuring that all the processes which are running, they are running smoothly, they are working in close proximity to each other, and each of the process is generating the desired output. So all these all the processes which are process engineering processes, these processes are actually governed by or are controlled by or overseen by a high level team of management, and which encompass the software management processes. So a large number of such management processes are also underway. Now when we talk about software processes, there are a few characteristics which become very, very important when we are talking about these processes. So any process which is working in the software development or which is a software process must have these 5 characteristics. First is the predictability. Second is support testability and maintainability. The processes should also support change. The processes should enable an early defect removal, and the process should improve on feedback. It should be a process which is constantly improving and evolving based on the feedback or based on any kind of input from the other processes. So now we are going to look at each of these characteristics in detail. So the first characteristic that we see is the predictability. Now what does predictability mean? Predictability of a process determines how accurately the outcome of following that process can be predicted before the project is completed. Like for instance, if we have a project A and we understand we are to take a project A, but we have already done a similar project 2 years back. So then we can say that the project is very similar to the one that was done 2 years back, and therefore the cost and time estimates of this project can be understood in the light of the previous project. So this means that the project A is quite predictable because the company has a past experience, and based on that past experience the cost and time variables can be calculated according to the previous previous experiences of the company. Then effective management of quality control activities depends a lot on predictability, because if the parameters are not predictable, if you are not sure of how the software is going to perform, how the software is going to behave, then it is very difficult to ascertain the quality. So certain amount of assurance or certain amount of surety, which is a pre-hand surety, is required before the work can actually begin. Then the software should also be under the statistical control. That is, we say that a predictable process is under statistical control. That is, a process under statistical control means that given all the other things are constant, if you repeat the process, then more or less you will get the same results. There will be very slight variation which will be due to random factors. So this means that the software development processes should also follow the statistical control parameter. That is, if you repeat the same process given the same conditions, then the result should be the same. So then if the software process is a statistically controlled process, then also we say that it is a predictable process. So predictability is a very important attribute which any software process should follow, because it is going to help the software developer in ascertaining, before actually executing the project, ascertaining the behavior of how the system is going to work. The second characteristic of the software process is that it should support testability and maintainability. That is, we all know that software maintenance cost, they exceed the development cost. So unlike the normal thought is, or the normal myth we can say is, that software development is basically coding. So maximum amount of time would go in coding. Whereas we must understand that coding consumes only 30% of the development effort, and time required or time spent in writing programs is less than 25% of the time of the overall project. So therefore we understand that testing consumes the maximum resources and time. So 50% of the project time is spent on testing, and it is very important to see that the testing is done properly, because any kind of bugs or any kind of defects in the system will be found out or will be taken care of in case of if a proper testing has been done. So testing does not only mean that testing the software codes or running the programs and seeing, but there are several dimensions to how the software quality is tested. Then maintainability of the software is also very important, because maintaining the software according to the requirements, according to the changes requirement of the users is important. Then also according to how the needs of the environment are changing. So therefore the software should easily be maintained, or any kind of bugs which are coming up should be able to remove. So testing means that you are finding out the bugs, maintaining means that you are removing any kind of errors from the software. Then the software processes should also support change, because we know that change is pervasive. In software development there is constantly changes are happening. There are requirement changes which are happening. A company may change its software because its business is changing, the business strategy or business plan is changing, there are more alternatives which are coming up, more possibilities are available. So the process should be such that it is able to handle the change easily. Once any change is coming up, so then all the software processes should be able to implement those changes, to accept those changes, and to put those changes properly into the new system or into the system which has already been developed. So change management should be easy in all software processes. Early defect removal is very important, because errors can occur at any and all stages of software development, and the cost of correcting errors depends on when the error is detected and when it is corrected. So they should be corrected and detected basically in every phase, because the more time an error remains in the system, the more fatal it can be for the system. For example, if the if an error occurs at the time of requirement specification and it is detected at the time of acceptance tested. So then the cost of that error will be 100 times more as compared to if the same error had been detected after the end of the requirement phase itself. So the errors or the impact of the errors on the system, it magnifies if the errors they percolate or if the errors they proceed down the software development phases. So the errors should be corrected on a very phased manner. After each phase, the objectives of all processes should be ascertained and the objectives are being met or not, and if any kind of logical or if any kind of understanding, communication or coding errors are there, then such kind of errors should be corrected. Then quality control should become a very important objective of all processes, because if the quality of the product will always depend on the quality of the processes which have been used to develop that product. So if the processes they are faulty, if the processes have errors in them, then certainly the product, the final software product which is going to be developed will also have errors in them. So therefore the objective should be to minimize the errors in all individual processes, and fewer defects are introduced at each time. For example, if defects are there in coding, if the coding which is done is has got too many errors in it, so then these errors will take too much of time of the training and maintenance of the testing and maintenance phase. So the cost of those errors will increase if they are not rectified and if they are not detected in the training, in the coding phase itself. So the errors of the coding phase should be dealt with in the coding phase itself, because otherwise testing and maintenance phase, detecting that error becomes difficult. The focus of the programmer should not be to write a simple program, but the focus should be to write a program which is easy to understand and easy to execute. So therefore if such a program is written, so it will become easy to find out any kind of defects which are there in that program. Then process improvement and feedback. So basically process is not a static thing, it is a dynamic entity. That is, it is constantly changing, it is constantly evolving. And software quality and productivity, as I just said, they are determined by the processes. Like for any product, the quality and the efficiency of the processes which are developing that product will determine the quality of the product. So same applies for the software also. The quality of the software is directly linked with the quality of the process, the efficiency of the processes. So basically the processes should be a closed loop processes. Closed loop process means that the current software or the current process should take a feedback from the previous processes and should also give a feedback to the process which was before it, so that the backward feedback will go and the quality of the overall process will improve. So feedback from the early parts of the project can be used to improve or execution of the rest of the project. So basically feedback should flow from each step or from each phase of the project to the next phase and from the next phase to the previous phase. That's why we are saying that it is a closed loop process, so that this will improve the quality of the processes, and this feedback mechanism of process improvement is very important in case of iterative for software development models which will be used. So because in each iteration the feedback of the previous iteration will help in improving the performance and in improving the quality of the current iteration. So feedback is very important attribute which a process should provide for improving its quality and its efficiency. So when we talk about software processes, now we will talk about certain generic models which are used. So software process models are used, a lot of models are there, and each model of course has its pros and cons, and each model has its specific characteristics which make it suitable for developing a specific kind of software product. So there are different models which are available, there are different prototypes which are available, and each prototype or each model can be applicable or can be used efficiently for a specific type of product. There is not one solution fits for all is not the case here. Depending on the nature or the type of the problem, a solution is chosen from the available models. So a few of the models that we will be discussing are the waterfall model, the spiral model, or the evolutionary model, in which the specification and developments they are interleaved. Then there is a formal transformation model, where a mathematical system model is formally transformed into an implementation. Then we have the reuse based model, in which the system is assembled from existing components and we reuse those components to build a new system, and then the user is allowed to work on them. So we will be discussing the individual characteristics of all of these models in the due course. So the first model that we are going to talk about is the waterfall process model. So as you can see, this model, the name itself suggests that it is a one unidirectional model, in which the steps or each of the phases or each of the processes, they are discrete from each other and they are disconnected from each other. So in this case we can see the first phase or the first activity is the requirement definition activity. The second activity is the software and the system design activity. The third activity is the implementation and unit testing activity. The next activity is integration and system testing activity, and the final activity is the operation and maintenance activity. So this model is a specific characteristic model which is used for very limited type of software development approaches. So the main features of the waterfall model are that these are separate identified phases. There are separate identified phases which are very earmarked, as you can see, which are very discrete from each other. So requirement analysis and definition, system and software design, implementation and unit testing is there, integration and system testing is there, and operation and maintenance is there. So the main drawback of this waterfall model is the difficulty of accommodating change after the process is underway. In principle, a phase has to be complete before moving on to the next phase. So it is like one phase is complete, only then you go to the next phase. But many issues are there such as risk addressing happens here. So this model basically is inflexible partitioning model of the project into distinct stages, makes it difficult to respond to changing customer requirements. So if the requirements change, like we have seen that the customer requirements, they change during the execution of the project itself, but here that is not possible. It is a very rigid kind of model in which the customer requirements are supposed to be laid out prior to the development process begins, because once the development process is underway, no changes in the process can be made. So this is only appropriate, this model is only appropriate when the requirements are well understood in advance and changes can only be limited during the design process. So very few business systems, they have a stable requirement. So this overall waterfall model is used basically for very large system engineering projects where a system is developed at several sites. So in those circumstances, the plan driven nature of the waterfall model helps in coordinating the work. Otherwise, this model is for smaller project where the requirements are quite fluid and the dynamic nature of the problem exists. In that case, the waterfall model may become problematic because the requirements keep on changing. Where the requirements are fixed, only in that circumstances the waterfall model can be used optimally. The next model that we see is the Boehm's spiral model. In this model, the process is represented as a spiral rather than as a sequence of activities with backtracking. So, each loop in the spiral represents a phase in the process. So, as we have seen, this is like an iterative process. So, no fixed phases such as specification or design are there. So, these are loops in the spiral. They are chosen depending on what is required basically. So, risks are explicitly assessed and resolved throughout the process. So, this was the motivation behind developing the spiral model, basically that risks can be assessed and they can be resolved, unlike the waterfall model where no changes or no adjustments can be done. The spiral model provides a more flexible kind of way in which the activities are taken up. So, you can see here in the spiral model the phased manner of the activities is being taken out. So, basically this is used in risk assessment and reduction, development and validation and planning. So, basically the spiral model it provides a more flexible way in which the software development life cycle can be implemented. So, we shall be discussing about more models on software development in the forthcoming lectures. Till then, thank you.
Thank you so much for giving us this session on software engineering. Friends, do write to us at info.cec@nic.in if you have any question. We are going to meet again soon and would be discussing more. Till then, take care. Goodbye. Thank you, ma'am. Thank you once again.